Hello. Now I am going to present Static Course Chapter 4 for System Resultants. First, I want to start with the body motion. If the force passes through to centroid of the body, our body makes translation motion. However, if our force does not pass through to centroid, our body rotates. In this case, we introduce new force resultant named moment. The moment is the effect of the force that causes the body to tend to rotate. If we want to compute moment at point O, in other words, point of a moment, we need two terms. First term is the force vector. We already know that. The second term is the position vector. Knowing the direction of the position vector is important. That's why we need to define the direction of the position vector. Direction of the position vector is from the moment point to any point on the force. So we need an infinite option. We can choose either option because any option we will get same result. Moment is equal to cross product of these two vectors. At the result of the cross product, the resultant term has a vector form. In other words, our moment has vector form. Point of a moment has vector form. So we need to know magnitude, axis, and direction of the moment. To compute the magnitude of the moment, we need to know the formula of the magnitude of the cross product. That is equal to magnitude of the r times magnitude of the f times sine theta. Here the theta is the angle between two r and f vectors. And also we can change the order of the f and r. You can see r times sine theta term in here. Within the help of that triangle, you can see r times sine theta is equal to perpendicular distance between the moment point and force. Also, we can say moment r instead of that perpendicular distance. As a result, our magnitude of the moment is equal to force times perpendicular distance. If we try to find the axis of the moment, we need a 3D coordinate system, and axis of the moment is perpendicular to the surface where force and position vector are available. To determine the direction of the moment, we can use the right-hand rule. For right-hand rule, we locate our right hand on the surface, and these four fingers show the rotation of the moment, and our thumb finger shows the direction of the moment. If we change the rotation, you can see also direction moment will change. Like this picture, if your force and position vector available on the XY coordinate system. In other words, we work on 2D space. Our resultant moment has parallel to z-axis. In other words, our moment has only one component, z component. In this case, we can represent our moment as a scalar form, and that brings easy to calculate the moment. And when our moment is negative and positive, to determine this negative and positive of the moment, we can say if our moment has counterclockwise direction, our moment is positive. If our moment clockwise direction, our moment has negative value. If we have more than one force, in other words, if we have more than one moment at our or point O, we just sum two moment values by considering the rotation direction. Let's make a practice on example 4.1. You can see in the example we have a beam and there are three forces act on beam, and in the question we need to find the resultant moment at point A. And in the question, magnitude of the force are given, so we need to find the first moment arms. First, I want to start with the first one, having 40 Newton value. And to compute the perpendicular distance, moment r, I want to draw line parallel to 40 Newton and pass through to point A. And then by drawing that line that shows the perpendicular distance, and after drawing that line, you can see there's a triangle occurred, and within the help of triangle, we compute the perpendicular distance as 3 times sine 60, that is equal to 2.598. If we multiply with that perpendicular distance to magnitude of moment, we will get 103 times 92. Also, I put the negative term in here because our force rotates the clockwise direction. For the second force, I want to extend, also I want to add additional line from here, and I draw a perpendicular line from that extension of the moment direction. So that triangle, by using this triangle, I can compute to that perpendicular distance, that is equal to 1.5 times sine 45, that is equal to 1.061, and we multiply with similar to previous force, magnitude of the force, and we will get 31.83, and I use the positive value of that moment because that force rotates to counterclockwise direction. For third force, I need to draw two lines. The first line is the pass through to our force like this. Also, I want to draw one more line in here. Then I draw like I want to show in here like better. Yeah, and you can see, and that distance are the perpendicular distance. And here you can see a triangle in here. Within the help of triangle, I compute this part of the distance is 6 times cosine 45. And we add that distance, we already know from here, that's equal to 3. That's why our total moment arm is equal to 7.243. We multiply with the magnitude of moment, this value, and we will get to 144.85. I put the negative sign because that force rotates to clockwise direction. So at the end of the question, we have 3 moments and we sum, and at the end of the summation, we will obtain minus 216.94, and that minus means that our moment has clockwise direction. Maybe you realize that it is a little bit hard to find two perpendicular distance because we need to use the geometric tricks. Alternatively, if we separate our forces and distance in the rectangular components, and multiplication of the moments a little bit easier. That brings more computation, but we don't need to use the geometric tricks. Let's try to make a practice on example 4.1, 4.2, and in this example 4.2, we resolve example 4.1 by converting force and distance terms into rectangular component. And I want to start with the first force, 40 Newton, and these are the X and Y components of the 40 Newton. You can see X component is passed through to point A. That means dy, the perpendicular distance for X component is equal to 0. That's why we only deal with the Y component, and also perpendicular distance moment arm is at 3. That's why we multiply by 40 times sine 60 times 3. We obtain the 103 times 92. Again, I put the negative because that force rotates the clockwise direction. For second force, you can see that parallel to x-axis, in other words, there is no y component, only x component, and perpendicular distance also has only y component. We already computed that moment arm that is equal to 1.061, and multiply with the 30 Newton, we obtain the 31.9383. And I put the positive because that force rotates the counterclockwise direction. For last force, we separate the x and y components in here. Also, to determine the perpendicular distances, I used this triangle. And by computing that distances, we can easily get the dx and dy value. The x value is equal to 6 times 3 times cosine 45. The y component is equal to 3 times sine 45. We multiply by these values with fy and fx. We will obtain minus 30 and minus 140 times 85. I put minus terms in here because both these components rotates to clockwise direction. At the end of this solution, we have 4 moment values. If we sum these 4 values, we will get same value with previous solution. This is the end of the section 4.1. Thanks for watching.